Happy to. So, thanks for inviting me. My name is Kevin Vance. I made this little cartridge here, which I have half uncartridged, which puts a Raspberry Pi into the Commodore 64's expansion port and pretends to be a ROM cartridge. So that's the little hobby project I've been working on for the past a long time now, and the internet just noticed it like last month. So it was very cool to see that people are interested in it. So if you haven't seen it, I'll post it into the chat, or I guess I could just share my screen. Let's see. So if you haven't seen it, real quick, this is the little video I posted. And it's just the Raspberry Pi in the expansion slot. And then, hey, it shows the Raspberry Pi or logo.
Cool.
So what's neat about that is that the program to display that logo, now it's just going to autoplay other videos. That looks like a good one. What was cool about that is that it's emulating a 16K RAM cartridge, and that program to display that image is more than 16K. So there's actually more stuff going on there as well, which I can get into later. I need to make YouTube stop. There we go. So anyways, I can tell you a little bit about who I am, what inspired the project, how I developed it. I have lots of prototypes I can show you, how it works, and what I want to do with it. So a quick introduction for me. Now, you know what the thing I made is. I'm a software developer from Pennsylvania. My very first computer was a Commodore 64. And I've pretty much just been lugging it around from place to place. It's been broken for a long time. And I finally decided in 2020 to fix it. And it was real easy to fix. It just needed a new power supply. So once I got it working, I started messing around with it. And at the same time, I was like looking on YouTube for videos to learn how to program it. When I was a kid, I could write basic programs and copy stuff from those code listings, but I didn't really understand how it worked. So I found this great video called something like 6502 Hello World from Scratch by Ben Eater. Which is not what I was expecting at all. He starts with a breadboard and a 6502 processor, and builds an 8-bit computer to run Hello World on. So as I was kind of doing those two things at the same time, like my brain started to understand how I could combine them. And once I got like just a little bit of knowledge, enough to be dangerous about how an 8-bit computer worked, I just decided to go for it. So at the time I had just started messing around. Like, I'm not familiar with electronics at all. I have no idea what I'm doing. I can't believe I got this far. But the very first thing I got was an Arduino. It was part of I was following along with that 6502 from Scratch series. And you build a little logic analyzer out of it. So you can watch, the instructions go back and forth on your little custom breadboard 8-bit computer. And I thought, could I just make this thing send stuff back? And I'm not the only one to think that, because I looked on the internet, and someone else had asked that on like a little Stack Overflow type site. And they said, no, the Arduino is much too slow to get the kind of bus timings you need for that. You could use something like the PSOC5, which I looked at. It's a pretty fancy microcontroller. And I decided to go for it. I had an idea that I really just wanted to make, to test things out, a spell checker, hardware spell checker accelerator, because you cannot fit the English language onto a reasonable amount of floppy disks. So I decided to go with that. I figured I will use this microcontroller. I read a lot about it. It seemed like it would work. I'll use that as the accelerator on the IO port, and I'll put some code on a ROM, and I'll put it all on a board and stick it in the Commodore and see if it works. And so much time passed. I watched a lot more YouTube videos. Like I said, I don't know what I'm doing. I learned this entirely from watching YouTube videos. I made a schematic and a PCB layout in KiCad, which is a great tool. It's very powerful, and yet I managed to figure out how it works. It's free, it's great. So this was mostly by like looking at the reference designs that you get on these data sheets. Fortunately, things were very easy, right? So they basically snap together like Legos. They tell you what the circuits are, and you can just put them, you can lay them out and hope for the best. To my great surprise, it worked. So I had this PSOC5 board. I started messing around with it. I actually I had enough of it together that I was like, okay, I'm going to send it off. I'm going to send it off to get built, which is another thing I couldn't believe, that you can just make a board design and send it to someone and have the board in a couple of weeks. That was very strange to me. I don't make physical things, like I said. I'm a software person, so this is all very fun and exciting for me. So that was, see if I can get that to show up. That was this little board, and that was so. My first mistake that I made was that I thought I knew how thick these were supposed to be. This is 1 millimeter thick, and if you put a 1 millimeter thick board into the Commodore expansion slot, it just falls out. Hence all of the wires soldered onto all of the contacts. So I did eventually end up testing it, just using this little prototyping board that I had put headers and stuff on. So I was, again, extremely surprised that, first of all, I could get this microcontroller to boot. And I could flash my code onto it, and that I didn't break my old childhood computer as soon as I plugged it in. And in fact, I did eventually, after a lot of work, start to get some stuff working. So at that point, I was using the Commodore's I/O port to do the hardware acceleration, right? The spell checking. So you would send a command, you'd start sending letters across the I/O port, and it would give you back yes or no. That was, again, couldn't believe I had done that, but it did seem to work. In order to get that to work, one of the things I also put on here was a little, I don't know if you can see this, as these are pretty small chips, but a little tiny flash chip, because this microcontroller is very nice and very fancy, but it doesn't have a lot of flash on board. So it was around that time, I have it kind of working. I can use it from BASIC, but when I try to write machine code to use it, it's not working. The timings are no good. It's too slow. And around that time, that's when I saw the Raspberry Pi Pico announcement. And I looked at it, and it was just, I really thought, you know what? This project would be much better if I had just used one of those instead. It has lots of flash memory built in, so I don't need the voltage regulator and the flash chip. It's very cheap. It's probably a good 3 or 4 times cheaper than the fancy Cypress thing. And it has these very fancy programmable I/O controllers. And those were the things that I thought were really interesting. They let you do very fast, very predictable I/O. And it looked like, from what I read, plenty fast enough to talk to a Commodore 64. So I dropped that project completely on the ground and started again. And I thought this time, it was very hard to build that. So let me see if I can take the camera. Show me. So I thought, okay, I'll just, what I'll do is I'll just make one card and break everything out and put it on this breadboard so that I can experiment with it, and learned how poorly that works. None of this is a good idea. It was a great learning experience. I designed 3 iterations of this thing trying to figure out how to make it work. But all these wires are just big antennas, and this breadboard is just very electrically noisy. I couldn't get much working out of that at all. So that was a lot of iterations. It's let's see, it's 2021 at this point. But I had learned enough that I thought, all right, I'm just going to have to make a board. with this, and that's what this one is. So this is the Pico 8K. This was the first design I made with the Raspberry Pi in mind. It has, at this point, kind of two little buffers, because the one downside of the Pico is that it's not 5-volt tolerant. Everything on the Commodore is 5 volts for the digital stuff. So I had to not fry the Pico. So that's what two of those are. And then for the data bus, I have this this little bus transceiver that you can tell it to listen or to talk. So I gotten around with that. I kept working on the Pico stuff, and the more I mess around with it, the more I realize that it's actually fast enough, and it has this built-in DMA controller that I think I can just hand off from the programmable I/O controller that's reading all the stuff off the Commodore bus to the DMA controller, and just have it access the Pico's own static RAM. And timing-wise, it looked like it should work. And this was the board that I tried to actually develop that on at first. And after much trial and error, I did eventually start to get some data. At first, it was only 4 bytes of data, and I couldn't figure out why. And that was because I forgot how C works. Size of doesn't work that way. So once I realized that I had actually copied the right amount of data over, I was very surprised that I had managed to make a little window to let the Commodore talk to the RAM on this thing. And so now I have a completely dynamic quote unquote ROM that I can do whatever I want to, and the CPU isn't even involved. It's just handing off between the PIO controller and the DMA controller on the chip. So the CPU can be doing whatever it wants. It's nothing timing critical. So I just kept going from there. I made one more iteration. At this point, I put a little AND gate because I realized that it didn't matter which of the fake ROM chips that the Commodore is talking to, it's all going to the same place. So if I just copy those signals together, then great. Then I can use all 16K of the address space. And then the last iteration on that one, I think I actually have a Pi on here. It's this one. And kind of as I'm doing this, I'm like learning more and more about PCB design. So the boards are getting smaller and smaller. And this is the one that it kind of all started working with. I had gotten rid of the bus transceiver because if I'm just emulating a ROM, I can just always write to the data bus. I never have to read from it. And I had gotten a little more sophisticated with my PIO logic. So now not only can I look at whatever address is coming through and send it on over to the DMA controller, but I can decode some of that address. And if it's in a certain area, I can say, well, just grab that byte or however many bits I want off the address bus and put it in a command queue. So you can read from a certain area, a certain block of addresses, and that's equivalent to writing a command byte to this chip. So that's how I was able to make some bidirectional communication while just emulating a ROM. So the kind of last iteration, and that's this one I built here, is I was trying to figure out if I needed to like 3D print something to actually make a real life cartridge out of. And I saw the future was 8-bit had these very nice, clear and multicolor cartridges, and they're very small compared to some cartridges that I have, but they did look big enough to fit a Raspberry Pi Pico in. So I gave it one more shot, and I just barely managed to fit the board on there. There's not much clearance. And put a mounting hole right in the middle, which is just the most annoying place you could possibly put it. So anyway, that really tested my newfound YouTube based PCB layout skills. So I have at this point that's all the prototypes I have. So at this point, I have kind of a command queue system set up. And I had one more trick that I figured out, which is that I need to, because a lot of the stuff I'm doing, it takes more than one Commodore CPU cycle. So I need a way to let the Commodore poll to tell if I'm busy or not, if there's no more room in the queue. Fortunately enough, the Pico has a status bit that you can configure based on however you want it to react to its own transmit queue. So I pretty much just have a system where you can read. I did one more address decode. You do not have a lot of instruction space in this PIO controller, but I did manage to get one more address decode in there to make a little status register that just, instead of copying that command byte over to the CPU, the Pico CPU, just copy the status bit onto the data bus. And with that, I have enough that I can make a I have enough that I can make like a full like bidirectional communication system. I can have the Commodore talk to the Pico. I can have Pico talk to the Commodore. So that's when I started to go back to my kind of first demo program. So that was the image that I displayed. I forget the name of the program, but there's fortunately somebody has written a very nice converter that will just spit out program code from an image. And so how that works is, what I really have is in the 16K of address space that I have on the Pico, I just have I decided, well, this 1K block will be my copy source. And I'll just put the first K of that, or kilobyte of that image at this address space. And, so when the cartridge boots up, it'll just start copying a kilobyte at a time, and it'll write, a command, say, hey, next page, to the CPU. It'll pull that status register until the mem copy is finished, and then it'll copy the next page of data over and over and over until you've got your full 23-ish kilobyte image displaying program in the Commodore's RAM. And that's what's happening when you boot up that particular program. So that was kind of, it exercised all the pieces of the hardware that I wanted to test out. So at this point, that is kind of where the project landed. It's all up on GitHub. I have the the schematics, the PCBs, the Gerbers, the code for the firmware, and the code for the machine language code that does the copying and jumping, basically. That's all up on my GitHub, and I can post a link in here at some point. I don't have it on me right now. So from there, where I want to go is, I do still have a bunch of the code that I was writing for my original design, my original hardware spell checker that I'd like to port over. It's a completely different system, but I think a lot of the C code will still work. I was writing my very first kind of Commodore quote unquote game, which I have a little version of Boggle that was mostly finished, but that was when I was running into those timing issues with that original board. So if I can get all that stuff ported over, it would be so cool. I started writing that thing a few years ago to actually get that all wrapped up. And then from there, there's some interesting stuff. I'm all out of GPIO pins. So people are asking, can you do like a RAM expansion emulation with this? And it's beyond me. I think you might be, someone might be able to. There's not enough pins for me to figure that out. But it would be very neat. I think you probably could do it on that original Cypress PSOC microcontroller, which is much fancier and more expensive. Though these days it doesn't really matter. You can't buy any of this stuff because of the chip shortage. So I'm not really selling or making them. There's no parts and I'm a complete amateur and would be scared of anyone trying to use it for real. These were originally made with, they're all, as you probably could see, they're all surface mount components. So this is me with a very fine tip soldering iron and a lot of patience and tweezers. Putting the tiny little components on the board. I eventually got a little hot plate that I could use that made that a little easier. Though I still have a lot of solder bridges and stuff to clean up. So it's all been very interesting. It's been a very cool experience, and there's more stuff you can do even without changing the hardware design, because there's still this USB port which you can use, and I used a lot to debug this device. But that does mean that at the very least, you can plug this in to anything that can use a USB serial port. So I have another project that will just send OPL3 commands into the OPL3 chip, which is a little FM synthesizer. So you could probably hook that up and get some OPL3 sound out of your Commodore with that, or I suspect lots of other interesting things you could do with that USB port. So that is, I think, all I have to say about that. I can go into lots more detail about how any of it works if you're interested. If you have any questions, now's the time.
Actually, I got one question because I found this really cool. I'm glad I'm recording it so I can rewatch it again. Have you documented any of this, like any of your steps? Maybe you put out an ebook or something like that?
I haven't documented the development process, though that is interesting. I didn't keep super good track of it. I have a decent amount of documentation on the GitHub. Let me find a link for that. About how, I'm not even signed in, about how it actually works internally on the firmware side mostly, because it's all, it took some effort. None of it was straightforward. But yeah, that would be pretty cool. There's like a kind of a 2-year journey there of being a complete amateur to making lots and lots of boards that eventually one worked.
Yeah, it sounds like this is one of those things that's like, well, I certainly would be interested in learning more about your journey in this. So definitely kind of akin to that book about, what's that video game? Prince of Persia. So the guy who wrote a Prince of Persia put out a book of all his diary entries as he was developing the game. So it's kind of like, oh, I wonder if this would be like a candidate for that sort of book.
Oh yeah, Jordan Mechner.
Yeah.
Yeah, I've heard of that book. I haven't read it. It sounds very cool though.
Yeah, it's on my list.
Oh, I'll jump in to say hi. Hey, Kevin, it's Leaf.
Hello.
Yeah, we chatted over Twitter, and nice to actually put a face to the name. I don't know, I'm just super psyched by your project. So a little bit of why I'm so excited is 6 months ago, I thought, I wonder if it's possible to hook up a Pi Pico to a 64 expansion port. And I came up with this.
That's great.
With all the level shifting and everything, and it was just barely starting to work. And I'm like, oh, there's level shifting and there's PIO. And then I heard about your project, and you took what was in my head and made it a reality. And I was just super excited to see that. So can't wait to play around with it some more.
That's really cool. It was very interesting when kind of the internet noticed the project. A few other people had gotten the idea as well and had shared their progress. It's not an original idea, but I think it is a very neat idea.
It's definitely a neat idea. I will absolutely agree with that right now. Kind of like, I want to do this now.
Yeah, it was a lot of fun. it was going from having this idea that, you know, it'd be really cool to make a Commodore 64 cartridge, to making not just one, but like a weird one. It was a lot of fun, for sure.
Not really a question. Oh, sorry,
No,
Jason from
go on.
Australia.
Please
Not
go.
really a question, but just more of a comment. It's I got really excited when I saw this because basically the Picos are the only chips that you can still purchase that are still available and at a reasonable price. So it'll be really good to see this develop into something.
Oh, that's great. I was looking
Reasonable.
around the other day and I couldn't find any to buy.
Oh, well, fortunately here, one of our main Raspberry Pi suppliers, everything is gone except for the Picos, and they're still really cheap, like $6 Australian. So, you know, like four US or something like that, which is, you know, very affordable. And yeah, so it'll be great to see this moving forward.
Yeah, that was another reason I really liked that chip enough to completely scrap my old project and try this out.
So you said that you weren't like you'd never played around with board design or anything like that. When you were working with the the PSOC chip, how did you find like programming them up? That's why I like the Pico and things like that, because you know they're probably a lot easier to program compared to the PSOCs and the Cyrus chips and all that.
That was, yeah.
Or Cypress, sorry. Yeah.
It was very weird. Some of it was very easy. The development environment for that particular one, I'm not a huge fan of. It's a Windows only software. And there's a lot of like dragging and dropping components to make these virtual schematics, and then it generates from those schematics a whole bunch of C++ code. So in a way that like when the drag and drop stuff worked, it was very nice. But when it comes to like doing something, you know, when I got to the trickier parts of this, like trying to wire up, you know, the PIO controller to the DMA controller, I had no idea how to do that in the drag and drop interface. Mm. There's also the matter of flashing it, which required a much more expensive dev kit to do to flash those chips instead of very convenient USB port you get on the Pico.
Yeah, that's what I mean. Like, because I played around with the project once with it, and it was just such a pain to get it to read and program. And
yeah, none of it was great. And with all that code generation, my goal, I want to put all this stuff, you know, on GitHub and open source it. I don't know if I can share any of the code that this thing generates, which is another reason I kind of didn't like it. No such problems with the Raspberry Pi, of course.
Yeah.
Did you find any other compatibility issues while developing this? Maybe with one of the other Commodore 64 types?
You know, I don't know. I just have, like I said, the one I grew up with. It's an NTSC machine. It's an old bread bin type. I don't think there would be compatibility issues. The clock speeds on the PAL machines aren't like that far off. I think they actually run slower. I don't remember, but not enough that I think it would mess anything up.
Okay.
It would be very cool if someone has one of those machines and wants to try it out. I'd be very interested to see how it works on other machines. And that's part of the reason why at least I wanted to make sure that I had all the files you needed to be able to send them off to, you know, PCB shops to get them made yourself, so that anyone who wants to can try it out.
Yeah, I'm going to get do a PCB order soon. I was going to get 5 boards made up, and obviously I'm in Australia, so we're PAL here, so I can do some testing down here.
Yeah, that'll be very cool. I did post the GitHub link in the chat if anyone was looking for that.
Is your Twitter page open as well?
It is. I don't post to Twitter a lot,
Yeah.
which is why I was surprised to see it really take off. I can post that as well, but I will be posting updates when I get back to this project. I did take a brief break for it as Ludum Dare was a couple of weeks ago. So a friend and I did that, which was a lot of fun. But I will post, there it's my Twitter. I will definitely be posting updates for this project on there as well, along with all the other random stuff that I'm working on.
This may actually be the kick in the butt I need to join Twitter.
Don't do it.
Why not to? I find Facebook and Instagram enough. Yeah, I definitely have that bookmark for sure. So you mentioned that you found the Benito stuff helpful then with this?
As like an introduction for someone who has no idea what they're doing, I found it invaluable. It was so interesting. I was following along with them as he was making them, and I was like, I would get so excited when a new episode would come out, and I could finally put the RAM module in my 8-bit computer, because it's just sitting on this breadboard waiting for the next episode to come out, so I can follow along with it. I found it very useful as someone who wasn't really familiar with 8-bit kind of computer architecture at all, to build one from scratch. It turns out you can do it if you have enough patience to cut all the many wires you need to make it.
Fair enough. Yeah, I did notice last week that he's selling his kits on his website on Benito.net. So definitely thinking of picking that up myself.
Yeah, I bought one of the kits to follow along with. It was great. It has everything you need in it. And it goes to support, the making of more videos, which is also great.
Also a plus for sure. For burning the software, did you need to use an EEPROM burner for that at all, or just the Pico tools?
For the Ben Eater project or for this project?
Either, or both.
So the 6502 from scratch project, you do need an EEPROM burner. If you are feeling adventurous, I mean, part of the project is you're making, again, this logic analyzer out of an Arduino. You can certainly use the Arduino to program the EEPROM as well. But the one that he recommends, it's very easy. It has software for Windows and Linux. I found it just getting started. It was enough for me to write my code and then just not worry about how to get it onto the chip.
Very cool. For the signal analyzing, did you find that really hard to figure out to do, or?
Sorry, what was that?
For the signal analyzing stuff, did you find that pretty hard to do at all, or?
To begin with, yeah, it's all very, especially on the breadboard, everything was very finicky on that breadboard, particularly when, you're blinking lights and stuff, and I'm watching the lights have 3 different brightness values and thinking, oh, that's not good. They should be on or off. Okay. I did eventually, I can show you one more piece of this, actually. I can show you this. So you reminded me with the logic analyzer. So as I was getting more comfortable with the Raspberry Pi Pico, I figured a great way to speed up my development on this is just to take the Commodore out of the picture entirely. So I just put another Pico on a edge connector, a little cartridge slot, and had it generate, the signals to, hey, read a byte, read a bunch of bytes, do all that stuff. And I eventually had bought a cheap logic analyzer, cheap USB logic analyzer that I could just hook up to that. And that sped up development a lot. I didn't have to have my 8-bit computer lugged into here and try to put logic probes on all its little pins. So that was, again, it's great when you have these cheap little, very flexible boards. You can do a lot with them.
That's awesome. I must say, I'm really impressed. That's
Well, thank
just
you.
so cool. And your excitement is clearly infectious, I might add. Oh, before I forget, if I have some time on the weekend or early next week, can I take your part of the talk and put this on YouTube?
Yeah, feel free.
Okay, thanks. I always try to ask beforehand, but I didn't think to do so now.
Oh, thanks. I see people following me on Twitter.
Oh, you actually had people just join with you now?
Yeah, I think I just saw the number go up.
That's kind of cool, I have to say.
Ah, nice.
Do you have a future plans that you're thinking?
So
Are you gonna modify with this? Like what are you planning to continue with this? What's your next project?
So with this particular design, I do want to see kind of how far I can take it. So there's a couple directions, right? I want to try and get my old spell checking stuff working on it, because I think I can finally get all that stuff working for real. And I also want to see, right now, you know, it's got this USB serial port on it. I am wondering what kind of options I have with that USB port. Can I use it as a USB host device and plug all manner of interesting peripherals into it? So that's something I haven't really explored at all yet, but could be very interesting.
Like kind of being able to control USB devices from your Commodore 64?
Yeah.
Ooh, interesting.
Yeah, I don't know what the capabilities really are of that USB port. I've only used it as a serial port so far, but it could be some interesting stuff there.
Yeah, I want to try having the USB port with the sort of a peek poke interface over USB over serial. So from a host PC or another device, you can write memory directly into, or you write values directly into the emulated ROM and have the 64 see it in real time. That could be really interesting for just development, or also maybe visual effects or something.
Yeah, for sure.
A quick question. Do you think the Pico is fast enough to use, let's say, an I2C interface to, let's say, an EEPROM for added storage or to act as RAM, something like that.
You're
That way,
coming in pretty quiet. Could you repeat that?
I was just wondering whether or not you considered using, let's say, a serial RAM or something through an I2C connected to the Pico, because you said you were running out of pins. Do you think it's fast enough to be able to move data from the parallel on the C64 to something that's I2C based?
So I'm not familiar with I2C. I did, when I was poking around at trying to figure out if you could make an REU with this, try to look at if it's possible to use like a shift register or something to output even just a few more pins on that parallel bus.
There are I2C data extenders, like an I2C port that goes out to like 32 additional IO.
Figure out if you could make an REU. Pat, your audio is really choppy. I can't make out what you're saying. But yeah, I don't know. That's about the point in the project where I was like, someone who is better at this stuff and has more experience with it, they could probably do it. That's why I open sourced it.
Has anybody forked it yet?
There have been a few forks. I have not received any pull requests.
Interesting.
A couple people have left people have left interesting discussions in the issues, particularly about the REU, which I didn't even know what one of those was when they left that comment.
But you had somebody who was working on a REU project. I can't remember if there was a GoFundMe link or some such thing. But somebody is developing similar. Let me see if I can find it in my email. Just a moment. Could swear I saw something about it.
Yeah, when I saw that, I thought that those look really interesting. Let's take a look on eBay to see if I can get one to play around with. And the answer was no. They're very expensive if you try and get one. I suppose they're rare.
I've seen them. They were fairly popular back in the day. I could swear I saw one. I'm just gonna be in the background looking for it because it's gonna bug me if I don't find it. Oh, was this from Jay Burrell? Yep, this is it. Pretty sure this is it. I'll post a link in chat. Just a moment. There we go.
Okay, yeah. I put an FPGA on there. You could do pretty much anything. That looks very cool.
And in there is another link. Why am I thinking GoFundMe or similar? Could be I'm dreaming, of course. That's always a possibility.
Yeah, it would be very cool to make something that's compatible, especially with the Pico, because they're very cheap. I think you probably could make one with that PSOC that I was playing around with, because it's not an FPGA, but it does have like little registers and things on the edge that you can hook up to make that kind of stuff maybe more possible. Also has just a ton of I/O pins.
That's one where you're saying that you weren't sure you can release all the code.
Yeah, I wasn't sure what that was. There's a lot of code generation in that SDK, and I was not clear to me initially whether you can redistribute any of it.
Interesting. Yeah, I wonder if that would be a real problem. It looks like I'm coming up with a lot of web hits when I Google for it. So Go for Retro has a post from 2018. Zimmers.net, new RAM link. Microcontroller based. This one doesn't look like it's been updated recently, but I'll post it in the chat as well. And on DuckDuckGo, there's a Google search for building an RU for the C64. That's a first for me. So DuckDuckGo has a search into a Google group for searching. Okay, why not? Yeah, I'm sure everybody else can do their own searches if they're interested. But yeah, looks like there are people working on it from this look of it. That's pretty cool.
That looks like a really fun project to do.
Any other questions? I guess if anyone else has any questions, they can reach you through Twitter. Or
Yep, sure thing. Twitter is probably the best way to get a hold of me. There's that feedback from Pat again.
Yeah, not sure what's going on there.
I'm glad my audio does seem to be working for most people. I don't usually do teleconferencing on this computer.
Don't tell me it's a Commodore 64.
No, it's my gaming machine. I figured it would probably be the better choice than my work computer.
Wise. One's gaming computer is always more powerful.
It's more powerful, but I'm not sure how stable it is.
Yeah, stability is overrated. So I'm just wondering if you want to get the business meeting started or not.
I've got to leave now, but thanks, Kevin, for going through it with us.
Yeah, absolutely. Thanks for listening.
All right, no worries. And I've followed you on Twitter, so I'm one of those people.
Jason, thank you for joining so far away. It must be very early there.
Oh, thank God it was 9 a.m. so it wasn't too bad. Normally these things fall, like 3 in the morning or something like that. So.
Well, please join us again. We'll be having another meeting next month for sure. It's always
no worries.
the third Thursday of the month, and we'll be posting the link on Facebook and on our website.
Excellent. All right. Have a good night, everyone.
Good night. Have a good day.
Yeah.
Okay. Thanks, Kevin.
Ooh, lots of chats going on now. Let me just catch up quickly. Yeah, Pat, don't worry about anything you missed. I'm going to be posting at least this part of the chat online on YouTube at some point, and we'll post it to the Toronto CBM mailing list when I do, and on Discord. It just won't be tonight.
Yeah, Kevin, you got to come hang out with us on Discord.
God,
Oh yeah, sure thing. Send me I'm not a Discord person. Send me a link or something. I'll figure it out.
Yep, I'll put a link in the chat. That'll be handy for everyone too.
All right. I am not logged into anything on this machine, but I will be sure to join it when I get to my other computer.
Awesomeness. Do we want to start the business meeting next, or do we want to wait a bit before we start it?
Well, to be honest, I think we've got everybody we're going to have.
That's what I'm thinking as well.
All right. Well, I'm going to drop off then. Thanks, everyone. It's great talking to you all.